But that's what we try to do. Everybody good? Sure. Good, because I'm about to make your life even better because I'm going to teach you something brand new that you've never, ever learned before. How much more exciting can it be to do? I'm going to teach you how to add and subtract and how to multiply and divide, something you've never done before. A bit of a twist in there today. There's this ugly word, not ugly, it's a pretty cool word, called complex numbers, which is a set of numbers that you don't know yet, that you're going to figure out here in just a minute what they are. So we are on day 4 of Unit 2B, complex numbers. You can see what we're going to do today. We're going to add, subtract, multiply, and divide what we call complex numbers. So what are complex numbers and how can we talk about them a little bit? So if I ask you to evaluate each square root without a calculator, and then explain to me how we know what each answer is. Now, what's the square root of 25? 5. What's the square root of 49? 7. What's the square root of 9? 3. How do you know those are the answers? What does it mean to take the square root? Kinda, yeah, but by what? The same number, right? So you're multiplying the same number together to get to it, right? 5 times 5 is 25. 7 times 7 is 49. 3 times 3 is 9. Taking the square root means that you're multiplying a number by itself to get to it. What about negative 25? Using that definition, is there anything that works?
5.
If I take 5 times 5 is 25. It's not negative 25. If I take negative 5 times negative 5 is 25. So that doesn't work. And by definition, it has to be by itself. So I can't take 5 times negative 5 because that's not taking it times itself. It's taking it by its opposite. So that doesn't work. So at this point in time, there's really no way we can do that. However, we can introduce this new thing that's called an imaginary unit. And this is for your notes. An imaginary unit. The imaginary unit. I is the imaginary unit. There's nothing else that's the imaginary unit. It's just I. Now, the next two things that are sitting there need to be highlighted, starred, circled, bolded, written bigger. All of that kind of stuff. Because you need to know those two things. That the square root of negative 1 is I. And I is the imaginary unit. So the square root of negative 1 is an imaginary unit. It's I. You also need to know then that I squared is equal to negative 1. So now that you know what an imaginary unit is, an imaginary unit is square root of negative 1 is I, and I squared is negative 1. If I go back to this square root of negative 25 now, I can rewrite the square root of negative 25 as the square root of 25 times the square root of negative 1. What's the square root of 25? Well, it's 5. What's the square root of negative 1? I. So the square root of negative 25 is 5i. Now you can do that. What's the square root of 49? Negative 49. Well, it's the square root of 49 times the square root of negative 1. Square root of 49 is 7. Square root of negative 1 is I. The square root of negative 49 is 7i. Square root of negative 64. What's the square root of 64? 8. What's the square root of negative 1? I. Square root of negative 64 is 8i. Okay. So the square root of a negative number becomes an imaginary piece of the world. And that's not what we're going to focus on too much today. We're going to focus more on that, square root of negatives. We're going to focus more on that tomorrow. And we want to be able to do that because if we think about what we did yesterday when we talked about the discriminant. The discriminant, we said, if it was negative, it had no solutions. And you had to essentially stop. Well, if we put that into the quadratic formula, now that's underneath the square root symbol. But we still need to be able to solve it. So tomorrow we're going to work on solving the quadratic formula with imaginary units. Our goal today is to be able to add, subtract, multiply, and divide imaginary numbers or complex numbers. So the unit itself, that's what we call an imaginary unit. When we have an imaginary part and a real part, it's what's called a complex number. Okay, so for your notes, complex number, and then I would just put this piece of it together. This piece in your notes. A complex number is made up of two parts. A real part, that's the part A. When we're talking about a real part, we're talking about a number. Talking about a real number. It can be any real number. It could be the square root of 2. Could be 27. Could be 32. Could be -8. Could be whatever. Could be pi. It's a real part. The second part of it is your imaginary unit, or your imaginary part, where you're going to have an imaginary unit. So 8i, the square root of 32i. That's the imaginary part, but it's made up of two parts, both real and imaginary. Now, in most cases, that's how we like to have it written. We like to have it written the real part followed by the imaginary part. If you write it the other way around, am I going to get upset? Yes. Am I going to count it wrong? No. Hey, be nice to me once and write it in that form because it makes things faster for me when I'm checking things. But I'm not going to get hung up if it's not that way. Okay, but realistically, we like to have it a real part and an imaginary part. So you're looking something like 4 plus 3i. That's what we call a complex number. Okay, it's made up of a real part and an imaginary part. So what we want to be able to do with complex numbers is, again, we want to be able to add them, subtract them, multiply, and divide them. And the nice thing about adding and subtracting them, when you add and subtract complex numbers, it's really the same as if you're adding and subtracting polynomials. You're combining like terms. So 4 plus 2i plus -6 minus 7i, procedurally wise, it's just like 4 plus 2x plus -6 minus 7x. It's the same thing. You're going to combine like terms. So when you're adding, remember the parentheses are meaningless. So this really is 4 plus 2i minus 6 minus 7i. And just take the parentheses out and get rid of the plus sign. It's not needed. Now we take our like terms. I'm going to take my real parts first. Those are like terms, and I'm going to combine them. 4 minus 6 is -2. Now I'm going to take my imaginary parts, 2i and -7i, and I'm going to combine them. 2 minus 7 is -5, so that's -5i. And that's your solution, and you're done. Okay, it's just like combining like terms. But now you've got a real part and you've got an imaginary part. So we've got that complex number formed. When we look at number 2, we've got 5 minus 2i minus -2 minus 3i. When you're subtracting, things become a little bit different. Your first set of pieces doesn't change. However, we need to distribute that negative into the parentheses. So -2 is +2, so that becomes +2. negative 1 times negative 3i. A negative and a negative makes a positive, so that makes that 3i. Now again, we do just what we did before. We combine our like terms. Combine your real terms first. 5 plus 2 is 7. Combine your imaginary parts second. Negative 2i plus 3i. So negative 2 plus 3 is 1. So we can just put plus I. Or plus 1i. It's the same thing. And that's your solution. So again, it just becomes putting the pieces together when you're adding or subtracting, combining like terms. Make sense? Good, try it. No, it's not even close. We have 4 objectives: adding, subtracting, multiplying, and dividing. Have we multiplied or divided yet? I'm so sorry. It gets harder, I promise. Since you're bored because it's so easy.
I'm not bored because it's easy. She just wants to know when we're done. Yeah.
She's bored because of math. I'm so tired of Enertson. Just think, next semester you get somebody else.
Do I take a math class? Oh, yeah.
Yes, you have to. You have to pass both semesters of this class in order to graduate.
How do you know I need someone else? What if I want you?
I'm not sure that's a possibility.
Why?
What if I'm not here? What if I'm not teaching Algebra 2 next semester?
You're not? Why? Ooh, not next semester? Wait, I don't know what teacher I am. I'm not going to teach Algebra 2 next semester?
Don't know yet. Next semester, maybe.
Please don't do that. I don't have you. You don't like it? Or what? He doesn't like us.
We hired another teacher.
Oh.
So the first one, just adding. So negative 3 plus 5i plus negative 6i. So we don't have anything to combine with the negative 3, so it's just negative 3. And then we've got 5i and negative 6i. That makes negative I. Yes? No? Uh-huh. Second one, subtraction, so we have to distribute. So it's 2i minus 3 minus 5i. Find my real part. Jeez, holy cow. Negative 3. 2i minus 5i is negative 3i. Did everybody get them right? Mm-hmm. Yay! I've taught you something today. I'm so proud. We can add and subtract. That's the easy part. Now the medium part, multiplying. So we get easy to harder. Adding is easiest. Subtracting is easy-ish. Multiplying is, still medium easy. But not completely. So 5i times 8 minus 2i. Again, think of it just like 5x times 8 minus 2x. Distribute. So if we distribute this, we've got 5i times 8. So 5 times 8 is 40. So this becomes 40i. Now we have to take 5i times negative 2i. So that's negative 10i squared. Okay, so then if we look over here, step 1, distribute. We did that. We distributed it. Second thing says change the I squared to negative 1 because remember, I squared equals negative 1. Every single one of you has that highlighted, starred, and bolded in your notes. Every single one of you, I'm sure, has done that. So anywhere we see an I squared, I can change that to a negative 1. So now We've got negative 10 times negative 1 sitting right there. So that becomes positive 10. Is this in the direction that we want it? No, not technically. It's bi plus a. So technically speaking, you should probably be nice to me and put it as 10 plus 40i. No, if you want to be nice to me, you do. If you're mad at me one day because of whatever reason, just maybe because you're doing math, it's understandable. It's understandable. And you can leave it like that. I'm not going to flip out about it. I can't tell you what Shara or Reinen would do. They might flip out about it, but I'm not them. So there's our solution. Okay. So the big thing with that is to make sure you change that I squared to negative 1. Anywhere you see an I squared, change it to negative 1. So then that leads to, okay, what if we have a binomial times a binomial? So we've got 5 minus 2i times 3 plus 5i. We're still going to do what we did when we had these before, FOIL. First, 5 times 3 is 15. Outside, 5 times negative 5i. 5 times 5 is 25, so that's 25i. Inside, negative 2i times 3 is negative 6i. And last, negative 2i times negative 5i. Negative 2 times 5 is negative 10. I times I is I squared. Okay. Now we got to combine like terms. So we've got 15 plus, we've got 25i minus 6i. 19i. That's plus 19i minus 10i squared. But what can I change I squared to? I can change I squared to negative 1. So realistically speaking, what does that last part turn into? That turns into plus 10, right? So now I've got 15 plus 10. 15 plus 10 is 25 plus 19i. And there's your solution. Okay. Again, I squared equals negative 1. I squared equals negative 1. I squared equals negative 1. Anytime you see an I squared, change it to negative 1. Multiplying by negative 1. So change the sign, right? If you're multiplying by negative 1, all it does is changes the sign. If it was negative 10, it becomes positive 10. If it was positive 10, it becomes negative 10. Save yourself some steps down the line so you don't have to write all this stuff down all the time. It's too much to write every single time. Okay? So let's look at 7 plus I times 4 plus 3i. Okay, you can FOIL it. I'm just going to use a different technique. I'm going to use the box method. If you want to FOIL it, you FOIL it. Remember, when you use the box method, we put the first one on the top, the second binomial on the bottom. We did this when we multiplied polynomials. 4 times 7 is 28. 7 times 3i is 21i. Inside, 4 times I is 4i. Last, I times I, 3i is 3i squared. Now we just have kind of the diagonals. When we think about the diagonals, 28, I've got 28 there. What's 3i squared? Careful, not positive 3. What's I squared equal to? Negative 1. So what's 3 times negative 1? It's negative 3. So this is going to be negative 3. So what's 28 minus 3? 25. What's 21i plus 4i? 25i. So that's one reason. And the box method can be nice. But again, remember, negative 3i becomes positive. Negative 3i squared becomes positive 3. Negative 8i squared becomes positive 8. Positive 7i squared becomes negative 7. I squared is negative 1. Switch the signs. So that's multiplication. Easy, adding. Easy-ish, subtracting. Okay-ish, multiplying. Fun-ish, dividing. Meaning harder. So the next question I have is I've got 5 divided by 2i. Mathematically speaking, in algebra, we do not leave i's in the denominator. You can never have an I in the denominator of a fraction. Let's go back to an English lesson. We said we're going to do sentence structure today, didn't we, instead? We don't leave I in the denominator of a fraction. What's denominator mean? Bottom of a fraction, right? Denominator is the bottom of a fraction. So should that say in algebra we don't leave I in the denominator? Or we don't leave I, if we don't leave I in the denominator of a fraction, aren't I saying of a fraction twice?
Yes.
Okay. So grammatically, see, I can't do sentence structure. Something to think about. Okay, so now that we've thought about the sentence structure, how do I get rid of it? Multiply by what? Itself. What do you mean by itself?
Multiply the 2i by the 2i so it cancels out into the 5 by the 2i.
Okay, so I multiply by 2i. Don't write this. So I multiply by 2i. So if I multiply the top by 2i, what do I have to multiply the bottom by?
By 2i.
Okay, again, don't write this. Don't write this yet. It's not wrong. It's not wrong. This could be done. Okay, but would I get the same thing if I did this instead? What's going to happen to the i's?
They're going to cancel.
They're not going to cancel because that'd be cross-multiplying, and we're not going to cross-multiply. If we cancel them out, we're just getting back to 1. We're not doing anything. But when you multiply fractions, you take the top times the top, right? What's 5 times I? 5i. What's 2i times I? 2i squared. But what's I squared equal to? -1. So what's the bottom really? -2. So the answer to this is 5i over -2. Okay. If I would have multiplied by 2i over 2i instead, right? Let's just talk about that. If I would have done 5 over 2i times 2i over 2i, that gives me 10i over 4i squared, right? So that's 10i over 4. But what can I do with the 10 over -4? I can reduce the fraction now, right? Becomes 5i over -2. Get the same answer. You just have to do more work. You decide. Now, have I changed the value of it by multiplying by I over I? I over I is really just multiplying by 1, right? Yeah. It just gets rid of it. Kind of like we did radicals. We couldn't leave a radical in the denominator. Couldn't leave the square root of 2 in the denominator. So we multiplied by the square root of 2 over the square root of 2. Same concept. Okay. Same exact concept. Okay. So let's look at the next one. 3 plus 8i over 2i. Okay, becomes a little bit more complex of a problem. Concept is still exactly the same. I'm going to multiply by over I. But now, because that's a binomial, 3 plus 8i, we have to put it inside parentheses and distribute. I times 3, 3i. I times 8i, 8i squared. We'll come back to that in a second. 2i times I is 2i squared. Okay, but now let's look at the numerator, the number on top. This would be the same thing as 3i times 3i minus 8. Remember, I squared is negative 1, so that's 8 times negative 1, which is negative 8. On the bottom, it's going to be negative 2. It's gone. There's your solution. And leave it like that. Technically speaking, yeah, that's probably not the prettiest way in the world to write it, but I'm not overly concerned with you writing it the prettiest way right now. I'm concerned about you being able to make sure that I isn't in the denominator. We don't like that negative in the denominator for the 2 either, but it doesn't change anything really. Okay. So then it leads to, again, we've gone hard, harder, hardest. So now we've got this 7 plus I in the denominator. So it's not just an individual term. It's not an imaginary unit now. Now it's a complex number. We still can't have i's in the denominator. Okay, so the way we deal with this one, we still just have to multiply by 1, something that's equivalent to 1, but the way we do this is considered inside parentheses. What we're going to do is we're going to leave the real part the same. So that's just going to be 7, which is the 7 from the denominator. We are going to change the sign. So it was plus, it's going to become minus. And then you're just going to put the imaginary unit there. Okay. So my denominator was 7 plus I. We're going to multiply that by 7 minus I. And you'll see what happens when we work this out. Okay, so now we're just multiplying. We're foiling. 7 times 8 is 56. Whoa. 8 times negative I is negative 8I. 2I times 7 is 14I. 2I times negative I is negative 2I squared. Are you okay with the numerator? The math look right? There's more we can do with it. We'll do with it in a second. In the bottom, you don't use an eraser. 7 times 7 is 49. 7 times negative I is negative 7I. And then inside is I times 7, which is positive 7I. And that's the exact reason why we have to change the sign. Because now that middle term goes away. That's why we just change the symbol, nothing else. Just change the sign, nothing else. Minus I times I is I squared. So if we look at the top, if we look at the numerator, I've got 56 right there, but I also have negative 2I squared. I squared is negative 1. So negative 2I squared is actually plus 2. It's the opposite of it. So 56 plus 2 is 58. Negative 8I plus 14I is plus 6I. Yeah. Plus 6I. In our denominator, we've got 49, We also have negative I squared. Negative I squared is the same thing as minus negative 1, so negative I squared is actually the same thing as plus 1. 49 plus 1 is 50. Negative 7i plus 7i, that goes away. That's your solution. There's not an I in the denominator anymore. And again, what we did was we took negative 7, the opposite. We changed the sign, left the real number alone, changed the symbol, left the imaginary part alone. Okay. Last one, I promise, for the day. Ooh, another long day. Man, these videos are getting long. Oh, that's nice of my wife. Target pharmacy was closed today when she was there to pick up my medications. So she's driving back to town to go get them, so I don't have to. That's so nice of her. What do I multiply by? So we've got negative 3 plus 3i over 2 minus 5i. What am I going to multiply by? 2 plus 5i. Leave the 2 alone. Change the symbol to plus 5i. Finish it. See what you get. Finish it. See what you get if you finish it. After school, you should, if you have time, go enjoy it. It's like 47 degrees right now. So nice. That's like shorts weather. If you have basketball practice or hockey or swimming or dance or wrestling, have fun. We have to sit and stack it over. Nothing better.
I'm so confused.
Spending the whole day teaching and boring you guys to death. And then we get to be bored to death for the next hour after that.
Won't you change the sign to it?
What's that?
Won't you change it to a negative or a minus?
Oh.
The top one? Or no?
No, we'll just leave it as plus 5i, because we're just, you gotta do the same thing. It's just the opposite of that thing.
Oh.
Not the opposite of it, but. Three times 2 is negative 3 times 2 is negative 6. Minus 15i. Plus 6i. Plus 15i squared. Is that what everybody else got for the numerator? We'll fix it in a second. 2 times 2 is 4. Plus 10i. Minus 10i. Minus 25i squared. Okay, so I've got negative 6 and I've got positive 15i squared. So that makes that negative 15. So negative 6 minus 15 is negative 21. Yep. Negative 15i plus 6i. Negative 9i. Nobody seems to be disagreeing with me, so I'm going to go with that's right. We've got 4 minus 25i squared. So minus 25i squared is the same thing as 25. So 25 plus 4, 29. 10i minus 10i is nothing. There is your solution. Yay! That is adding, subtracting, multiplying, and dividing complex numbers. Tomorrow, we're going to work on the quadratic formula, but now what's underneath that radical might be negative. So we can deal with that tomorrow, okay? Your assignment is inside of Schoology as always.